This is section 4.3, video B. We're looking at solving these equations that contain rational expressions. And on example 3, we have something that we've kind of seen before. We have a couple of linear denominators that we don't need to worry about. But when we factor this one, we're going to end up with something that we don't maybe like quite as well as we could. It is a difference of squares, but since the 25 is first, that means the first terms will be 5 times 5, and then the minus x squared will make that a plus x and a minus x. Now I really don't want to count these as two completely different terms for my LCD, and so the way to fix this, which we've seen before, is to multiply top and bottom by -1. Again, I'm multiplying by a form of 1, which doesn't change the value, only the appearance. That's going to make the top a positive 20. And in the denominator, 5 plus x can just be written as x plus 5 just because I want to, right? Those mean the same exact thing. I'll use the -1 to multiply into the second set of parentheses and turn that into a positive x and a minus 5. Now, looking across here, I can see that my domain, oops, let me move that down so you can see that, my domain is x cannot equal -5 and x cannot equal positive 5. Same thing here. And the least common denominator is just going to be x plus 5 times x minus 5. All right, like we've been doing, we're going to multiply both sides of the equation by the LCD. I'm going to see if I can sneak it into this line right here. I'm going to multiply this side by x plus 5, x minus 5. I'll put that over 1. And I'm also going to multiply this side by x plus 5, x minus 5, which I can put over 1 as well. On the left side, I've got the two terms, so I'm going to have to distribute this. When I distribute to the first fraction, the x plus 5 factors will divide out to 1, so I can get rid of those, and I'll just have -2 times x minus 5. Plus, in the second term, it's the x minus 5 factors that divide out, and I'll get 3 times x plus 5. On the right-hand side, we only have one term inside these brackets, so I can just go right ahead and say the x plus 5s divide to 1, and so do the x minus 5s, which leaves me just 20 divided by 1. Or 20. All right, nice equation now, no fractions, so let's just simplify. I'm going to distribute the -2 and also distribute the 3. And combining like terms makes this x plus 25 equals 20, and so x is equal to -5. Now here's the whole reason that we like to list this domain. Even though I got -5 as an answer, x can't be -5. That was not in the domain because it made 0 in the denominator. Since that was the only possible solution, but I can't use it, that means there is no solution to this problem. All right, let's take a look at example 4. Looking at this, I definitely see things I could factor, so I'm going to do that first. A equals 1 in this trinomial, so I'm going to start it out with x times x. And then looking for a sum of -6, product of positive 9. I think negative 3 and negative 3 will do that. Second fraction, I can factor a 3 out of the denominator. Makes that x minus 3. And finally, the other side, I'll factor a 2 out, which also makes that x minus 3. So in every single factor, we see that x can't be 3. So that's my domain right there. As far as the LCD, I certainly have the 2 factors of x minus 3. But then this one has a 3 and that one has a 2 as a multiplier. So I'm going to include 3 times 2 or 6 as another part of my LCD. So I'm going to take the entire left-hand side and multiply it by this LCD. Put it over 1 just to keep track of things. And then similarly, I'll take the whole right-hand side, which is not nearly as much, and I'll multiply it by that LCD. All right, this is the step that looks messy, but it's the one that gets rid of all the fractions for us, so it's worth it, right? On the left, I do have a distributive property because I've got the 2 terms inside the brackets. The x minus 3's, both of them, will divide out, and I'll just end up with 3 times 6, or 18. So that one was really nice. Over here, well, let's see. For starters, 6 divided by 3 is going to give me 2. One of the x minus 3's will divide out, and then I'll have the x minus 2 times another x minus 3. All right, the other side. This one's nicer because I've only got one term inside my brackets. 6 divided by 2 is 3, and one of the x minus 3's will divide out. So I have 3x times the other x minus 3. Again, if it helps you to write out one additional step where you multiply the LCD by each of these, by all means feel free to do that. All right, let's work on getting this simplified. I'm going to go ahead and leave the 2 out here for right now, and I'm going to multiply those 2 binomials. So I'll have x squared minus 3x minus 2x plus 6. And distributing on the right-hand side gives me 3x squared minus 9x. Let's see, distributing that 2 gives me 2x squared minus 6x minus 4x plus 12. And bringing things together on the left side, I have a 2x squared, a minus 10x, and then a plus 30. All right, we're getting there. It is quadratic, so I know that I want it equal to 0. I like a positive x squared term, so I'm actually going to subtract and put everything to the right, because that way when I subtract the 2x squared, I'll have a positive 1x squared, which I prefer. That means I have to add the 10x and subtract the 30. Gets rid of everything on the left, and on the right I have x squared plus x minus 30. All right, if this is going to factor, and I think it does, it's a trinomial with a equal to 1, so I can start with x times x, giving me the x squared. And then I need a sum of 1 and a product of negative 30. And 5 and 6 will make the 5 negative, so they add up to a positive 1. And that gives me as my solutions x equals 5 and x equals negative 6. Neither of those were excluded from the domain, and so I can keep them both as perfectly good solutions. All right, now we're running a little long here, but we got one last example in this section. Let's knock that one out before we quit. Lots of factoring, so let's do that first. Another trinomial with a equal to 1, allowing me to start with x times x. And then I'm looking at a sum of 1, product of negative 2 here. So that would be a plus 2 and a minus 1 would do that. Second fraction. That's a difference of squares. X squared is x times x. And negative 4 would be positive 2 times negative 2. Last one, another trinomial with a equal to 1, so I can start with x times x. And this time I need a sum of negative 3, product of positive 2. I think a negative 1 and a negative 2 will do that. Multiplies to positive 2, but when I add them I get negative 3. All right, so looking at all of that, it looks to me like as far as the domain is concerned, x is not equal to negative 2, positive 1, negative 2, which I already have, positive 2. That just gives me 1 and 2 again. So those 3 values are excluded from my domain. As far as the common denominator, I've got x plus 2 times x minus 1. X plus 2 is already there. X minus 2, it's new. X minus 1, x minus 2, both already there. So there's my LCD. So I need to take the entire left-hand side and multiply it by that LCD. Then whatever I do on the left, I have to do on the right. So I'll also take that right-hand side. See if I can squeeze it in here. This is where you start when you're using your paper horizontally. We have so much to write. Again, I'm going to multiply it by the LCD. Scoot that over so you can see it a little better. There we go. All right. On the left, I have to distribute this LCD multiplier to both terms. So I'm going to start by saying in the first term that x plus 4 will certainly still be there. But once both the x plus 2 and the x minus 1 are allowed to divide out, the only thing that's left to multiply it is the x minus 2. Plus. Again, I'm definitely going to end up keeping that x plus 1. And here, both the x plus 2 and the x minus 2 are going to divide out. So the only thing left to multiply is the x minus 1. The right-hand side is a little easier because I can actually mark it off. There's only one term to worry about inside my brackets here. So I can actually say those will divide out. And so will those, all of them just to 1s. So I have x minus 3 times x plus 2. All right, got rid of the fractions, which is huge. we can now say we got some FOIL problems to do here. Let's multiply everything out and see what happens. Let's have x squared minus 2x plus 4x minus 8 plus x squared. This is one of those where the outers and the inners are just opposites, so they add up to 0. And then a minus 1 equals x squared plus 2x minus 3x minus 6. On the left I have 2x squared, a positive 2x, and a negative 8 and negative 1 make negative 9. And on the right we have x squared minus x minus 6. Once again, this is quadratic, meaning I probably would like to get it to equal 0. So I'm going to subtract the x squared, add the x, and add the 6 to make the entire right-hand side equal 0. All right, I've got a quadratic equation, but I'm a little nervous about this one because I don't think I'm going to be able to factor it. A sum of 3 and a product of negative 3 is just not going to work. So I'm going to have to go to my alternative method, and I'm going to have to solve this with a quadratic formula. It's been a few days since we've worked with that, so let me remind you what it looks like. All right, so let's see. B is 3, so minus b would be a negative 3. Plus or minus the square root of 3 squared. Minus 4 times a is really 1 here. Times c, which is negative 3. Over 2 times our a, which is 1 again. That's 9 plus 12 would be 21. And there are my 2 exact solutions. They're clearly not the ones that I excluded from the domain. Those were all nice whole numbers. And this certainly isn't. But it's still a real number. I didn't end up with any imaginaries, no negatives under the radical. So these are legitimate solutions to that rational equation. All right, that brings us to the end of 4.3.